John, Brant, everyone for warming up the crowd, getting it ready for me, being the opening act. That was awesome. I can't say thank you enough to everyone there. All right, want to go into a presentation because they're always exciting. Let me share my screen here, get that up and running. So I'm with Pointerra. We're an AWS cloud-based platform for sharing, managing, hosting, visualization, but also data analytics. And that's a big part of what I'm going to talk about today, and helping a lot of our utility clients as well as our service providers to utilities, electrical utilities generally. I know there's a lot of other utilities out there, including water and such, but this would be the electrical utilities for the purposes of this discussion. All right. In general, we sit on top, as I said, on AWS. We run our analytics there. Very thin client, so you can access it. Your people, you can do it from a desktop, from an iPhone, from an Android, from any type. The secret sauce in what we do is our spatial data structure and the ability to stream very large points at scale to users, and then to run analytics on that data at scale to get information out of it. So, and this comes down to, for the utilities, comes down to asking what questions they're trying to solve. What are the challenges they come up against? We were working with some today, as a matter of fact, going over some things, whether it was veg management, asset management, real estate, or any types of other new line design. They want to understand what moving things can do for them in the surveys they have. We can act as a common data repository for any type of data. We're completely agnostic as to who collects it and who does it. So that, for instance, if they have data from 12 different providers, whether it was airborne, whether it was sitting on top of a tripod or on top of a car, whether they have it in a drone or underground, we're pulling all that in. And then they provide a digital twin. If they want to do any assessments of a given asset, they can pull it out to understand the GIS locations and put in the attributions of each given asset they have. So the reason they do it is so they can share their data and get more use. I mean, they're investing tens, hundreds of millions of dollars on data collection. And really, because in general, they tend to have operated in a siloed manner, that tends to be changing, because as we get better at what we do as an industry and providing really great insight onto an asset, they can use it for different purposes. So if we can help them exploit the data they have and exploit the operations, change their workflow, they can get a lot more value out of it. The return on investment for certain utilities can be anywhere between 5 and 25 times that data and the spin they get on that, if they can understand. And when you think about it, if they can save one outage, or they can get people back on and save one day of additional crews coming in to help with an emergency, it gets into the hundreds of thousands, tens of millions of dollars, depending on the size of that time savings, and getting them critical information so they can make better decisions. Because the data we provide is exceptional. It's extraordinary. Goes back to why I'm with Pointerra today. We were providing some amazing data to a utility client. This was 3 years ago with the company I was with formerly, and it was beautiful data. And the utility client said, okay, we had 75,000 square miles of data for this utility client. And they said, send us points and lines for our network. And I said, but you guys have a full digital twin virtual network. Don't you want that? And they said, no, we couldn't use it even if you send it to us. And at that point, it clicked in my mind. We do such amazing, complex data acquisition and provide an amazing product that people can't see what they're paying for a lot of time. So in doing that and working with utilities from there, helping them understand the data they have and the value that's there, they can get an increased safety and keeping people off the poles. They can increase the reliability, get better communication, and better customer result in the end. And that's what they care about, is they can keep power on or be able to get it on faster in the event of situation. And we look around the world, whether you're on the West Coast with the fires, the East Coast with the hurricanes, the Gulf Coast with flooding, or the Midwest with some of the storms coming through there. It's been pretty extraordinary. In looking at what we're doing on our platform, we come in and you can see the entirety of a network. For instance, in this case, all of this area, they can go down and look at any given span, any given pole, all the way down to a given wire or a given tag on a pole that they get down to the bottom right-hand side. They can share that with their providers or with their engineers or with the decision makers that want to move from one side of the street to the other to help them understand better how they can do that. They can extract out of it to get vegetation management analytics, as it's shown here, to say, hey, we like to trim 8 feet from the outside conductor, 20 feet above and below our line. All right, that's great, except when you have this overage of vegetation and there happens to be a freeze or a heavy storm, that ends up causing reliability issues. So the question comes back to how much more do I have to cut and what's the cost of doing that to be able to ensure my reliability can increase? So these are some of the questions we help them answer. And not just answering it, not just color coding points, but exporting it out into a usable format, such as a shapefile. Sometimes it's a CSV, sometimes it's a GeoJSON, so that then it feeds into that next part within the workflow, within the utilities. This is our customers a lot now are putting in just calibrated point cloud to the point of some are just pulling it straight out of the sensor and posting it to our platform. And then it's extracting out building footprints. It's extracting out wires, poles, guy wires, service wires, as you can see some in here. It extracts out the connection points or if there's joint use, and it just identifies that. Depending on the level of information that's input, they can pull all this information out of it and then segment it to the different business units within the utility to give them information and making better decisions. These are some of the additional attribution analytics, lengths, bearings, sag, pole loading, the engineering analyses they're putting into it. You can get clearance. This happens to be distribution on these, but we do the same thing for towers and tower legs and coming in to understand what's it look like. Certain clients are putting in full method 4 PLS CAD type information in or full reality capture, and they're getting a digital twin generated so that they can actually look at all of their assets, share that assets, and then go out to customers. One of our customers right now, they had a full area. It was a town or a small city that had their highest reliability issues with their latest storm. Their issues were the city and the residents there didn't like them cutting the vegetation because they liked their trees and they thought it was terrible that they would cut these trees. Well, they thought it was even worse when the storm came through and the branches from these trees caused outages and it took them 3 to 4 days to repair it, and they were upset that they weren't able to get their power back on. But it comes back to being able to explain that and show that to the customer saying, this is great, here's what's going to happen, and this is what it looks like. If you choose to do that, that's fine, but understand this will be the result. So it gives them a better communication platform when discussing that with the ratepayers. Some of these are some of the analytics that have come up with a couple of our clients. Tend to be more specialized toward the 5G optimization, mainly because the telephone, the cable providers are using this for their asset inspection and identification. One group went from, I believe it was 1.5 million poles that they had. They wanted to identify which ones would be proper siting for 5G antennas, and they needed to extract out 3D pole elements so that they could understand what it would look like using some AR as well as some VR when they went out to the pole and looked at how that was going to affect the pole loading for these 5G antennas being placed on that utility pole. This is always going to be the case. Esri is prevalent in, I don't know if all, but the vast majority of utilities. So we integrate with Esri kind of on a side-by-side viewing. I realized Esri recently ended up buying a LiDAR company and trying to integrate that, but there's still issues in working with full resolution point clouds for the data that's actually being collected to be completely compatible with Esri. Esri does a great job of keeping the attribution and all the information in there, but to update the location and the true attribution on a given pole for a utility company, for instance, to ensure that that's being seen in the same place and explaining what that looks like. Certain companies go out and they want to do photogrammetric inspection. We host all of that and put that in so the utilities can go get the inspection, but also make comments. This happens to be, these are examples of cell phone mobile antenna inspections, but the same thing applies. All right, we also have quite a few doing mobile with spherical imagery, ladybug cameras. Josh was talking about that, incorporating that, being able to annotate it, call it out as to where it would affect or impact different types of utility assets along the road or they're underground. And then the last bit that's come in recently is the BIM digital twin for facilities management, doing the indoor scanning, doing some type of SLAM scanning, getting an understanding of where safety features are, or HVAC, or fire extinguishers and equipment along those lines. So with that, let's into the PowerPoint. And what I'll do now is I'll stop my share and go into just a demonstration of what it looks like. Actually, if there's any questions, I don't see any questions right now, so that works out well. Please feel free to ask any questions. Mark will stop me. He knows how to do it. I've done my best to be a Padawan to Mark for years, so he knows how to stop what I'm saying. And let me share this back to platform. Show windows. There we go. All right. So this is what the platform looks like. This is just a demonstration of what we're doing with a couple of utilities. There's always going to be a 2D component that they can go look. They can see how large this actually is. This shows kind of my viewpoint in coming in here. And then you can come in and zoom into a certain area and say, okay, I want to align my 2D and my 3D. So in this case, I'm coming in and I'll make my 2D smaller. I'll bring it in here so that, for instance, I really want to see what this pole is. And I can turn around. I can start to understand what that looks like in line. Now this network, all of this data came in completely unclassified. The analytics ran the auto classification to extract out poles, wires, ground, vegetation, so that in this case, you can go over here and there'll be a window that talks about, you've run the analytics. You have a pole height of 41 feet. It's pole lean at 1 degree. And then you can go through and you can filter this. So for instance, if you want to come in and you only want to know certain pole lean, with certain numbers of spans, guy wires, service wires, distance to known, things like that, you can understand a little bit more. On this circuit, there's 449 poles. This has a span. You can look at the length, the bearing of all 3 of the spans coming off of this. Or you can actually go in and do a review on these assets. So if this pole, for instance, I'll go in and review this one. If I can click on it, there we go. And you'll see all the analytics that were pulled out. This was primarily for a pole loading and hardening program. And in this case, all these measurements are measured from the base of the pole to the top. And so each one of these gets assigned within a pole engineering application. So you can go and figure out if it's overloaded or if it has issues. In this case, you can go click on the images that came as part of this. This was a drone capture through one of our partners. And they can go look at the assets on the pole to get an understanding of what's on that pole and what if there happen to be defects in there. And so if they had a broken bell on an insulator or something along those lines, or for instance, if they wanted to come in and what they were really looking for was they were in here and they wanted to know what's the third-party attachment. And they come in and say, oh, look, I've got loops and I've got boxes. So I've got cable and I've got comm sitting here, and I can understand what's going on with my third-party attachments on this one. And they can update that. And in this case, let me see where we can come back out, zoom around, come back. Dang. I don't like this. Dismiss that. And we'll go into, this is a terrestrial scan by one of our partners called Flight Evolve of a vault that happens to sit below ground. And what's happened in this case is they can come in and they can zoom around and go look and see where it is. You can then go click on a given image for the spherical imagery from that vault and be able to see what was seen from that image looking down into the hole, and to see what it saw as they were looking in there. You can come back out, you can measure there, you can do volumetrics in that. In this case, we can zoom back out as we look down the vault hole itself, and they put a 3D drawing in here to do some clash detection to understand, in this case, what it looked like in here. And I'll put a near clip on here so we can look through here as we come in and take a look at how this matches up on an as surveyed versus as designed basis, and have an understanding of what it actually looks like in its current condition, and if there's things that need to be done to change it in any way. Are there any changes that need to be made on any of these panels? Are all the conduits all in good order, and everything within that area? One of the other things is that, and I'll go back to this one for a second, don't mean to jump back too much, but in this case, for instance, if this group wanted to export out their poles and wires in a DXF or a shapefile, they can export it out across here. They can download the files if they care to download them. They can download them in a GeoJSON, or in this case, I believe it is in the JSON for this one, so that it loads into pole form. And here's a dashboard that was created. We have a client of ours that likes working more in the 2D environment and having the 3D if they need it, so that they can see what it is on a map, and they can just go in. In this case, it has to do with, I don't know what that is. Oh, Season doesn't like that. So that they have all their imagery all in one place. They can then go look at the reliability. They can look at, in the reliability, they have their thermal imagery as part of it, and they can inspect their thermal. They can run analytics on that, and then the vegetation assessment of a given span for this circuit coming in. And then they can input it into their pole foreman, OCalc, into SpatiCalc, any one of those, and then get an assessment of a given pole and its attribution and its loading, so that they can have the full pole loading analysis report coming out of that, so that it helps them understand their assets in a much more effective way and be able to communicate what they can do, what they are doing, and what they need to do. In this case, this is one of our clients, and a good group that's very innovative out of South Australian Power Network, Stephen Williams. And so they've got their substation scanned in here. In this case, they have it all in. They've got their 3D scans in here, but they also find pits. And when their guys are out looking at their substations, they take pictures of things and then tag them back into the platform, so someone can look to say, hey, this is what this looks like on here. This pit happens to be well taken care of, and there isn't a maintenance need. In this case, they had a window that needed an assessment, so they brought it in and they took a picture of it so that they could say window, they annotated needed fixed, and then it was fixed.
I got a question for you, Randy.
Sure, Mark, go ahead.
Can you explain your pricing model? Is it based?
Yeah, it's a subscription-based service, and it's usually based on data and users, amounts of data and users, so that there's three sets to it. One's a subscription for data as a service. In other words, if you're just hosting and using it as digital delivery, because we work for a lot of smaller survey firms, and in saying that, we end up with groups that just say want to deliver to their clients. So for instance, in this case, if this client, well, it's a utility, but anyway, if they want to share it with their client, they can load it up, they can send it to them. And it's usually on the order of $1,000 per month per terabyte, and that includes 5 users. So if you're doing a half of that, it's 500 gigabytes per month, and 3 users, I believe is what that is, so that they can just deliver that up to that point. Now, if you want analytics and some of the things that you're seeing in here of auto extraction, auto processing, and the 5G analytics, those end up being an additional charge, and those end up being custom, mainly because certain groups want a lot more and other groups don't want as much. So, but the other side of it is one of the Aerometrics, who's going to be on here, they're a group we work with quite a bit. If you have data you want to put onto this isn't utility related, but if you want to put it on a data marketplace, we have a point of sale on there that people can go clip, ship data. You can deliver in that way so that it works like that without a problem. So, this is some data one of our clients are using with some fallen vegetation encroachment, and they're using it to run not only understanding where all of their assets are, but where they have risk associated, where trees and vegetation may fall in. So this gives some really, this client's very innovative in coming up with understanding, hey, where are the trees that I'm dealing with, and which are the ones I need to be most focused on, and where are they going to hit my line, so that, as you can see in here, this ends up coming in, and if you turn on more of the information that's been pulled out of this, you can start to find which tree is going to hit, where it's going to hit, and how much of the line will be impacted by that tree. So let me come back to, all right. So at that point, I'll open it up to a question. Can the processing results, yeah, you can export to CAD, you can export out to just about any type of format you care. We can export 3D CAD, DXF. I'm trying to think of the other ones. That OBJ are the exports that come out of there. The majority tend to be Esri shapefile deliverables or in a GeoJSON. Tend to whatever fits the next level of the work process and understanding what that is. So in this case, we work with aircraft data, helicopter data, terrestrial data, bathymetric data, just about any type of remotely sensed data you can think of. So I'll stop sharing this and turn around more for Q&A then. All right, I've answered my question. I'm really good at that, Mark.
There's a question mark in the chat from Brant Howard.
Yeah, that was basically the same question. It was about the delivery methods.
Yep, they can, you can share it. They can download it if they're doing additional design. They can export it. We've exported into back files for PLS CAD. It depends on the use case, what they're doing. We can export in any geospatial format that you would use as part of it. So the interesting thing are the analytics that are being run are being fed into vegetation management type programs. We have others that are being run into asset management that need more imagery based. We work with different imagery providers to run AI and ML type imagery defect analysis and anomaly detection. Work with fuel load with different groups and floodplain analyses, quite a few, whatever the application, if you can ask the data the question, it can be generated on the platform, but it's all deployed in the cloud. Give an idea of the savings going on. One of our clients was taking about 2 weeks per circuit with 3 folks to do that. They now do that in about 2 hours of one individual. So that accounts for running that. That's at a cloud-based compute and being able to export out the information they need. The 2 hours tends to be the QA/QC component. I don't know that we'll ever get rid of that. We can keep minimizing it and getting better at it. But we have groups that are uploading direct from sensors. So it's processing in the cloud as well, taking it all the way through to the point cloud and then the imagery, and then putting it together for the clients themselves.
Randy, do you have a next step for Pointerra? Is there something you're going to keep improving on or coming out?
Yeah, we currently, the roadmap is to take it back as far as the acquisition providers want, or the asset owners want, I guess I should say. We work on both sides of that so that they can import in an E57 from a terrestrial scanner, or they can pull it in and then ask the question and export it out to the given individuals that need the information to make a decision. Whether that's telling them which crews need to cut what tree, or which poles need to be changed out, or which lines need to be re-engineered. Depending on how that goes and what they're doing, those are the next step. And there's a lot of, we're being driven, the guys who are providers right now, the groups from maps that we work with, they want to take it back to say, we want to import in raw data from our systems, and then you get us to a point that our production flow can ingest and then run with it. And that's what we've been doing recently. Some of the stuff that's come up that are different for us and probably may need your help, and that's for you, Mr. Brooks, is some groups want to do cable line optimization routing on seafloor using different types of bathymetric data. So I'm sure that's an area you can probably help us out with.
I'm here for you, Randy.
Thanks, Mark.
Oh, we got one more question. Is any manual editing needed after having your deliverable?
Great question. It depends on what it is you're looking for. There's always a QA. There are some manual editing that folks do. On the utility side, if they're looking at figuring out pole heights, pole leans, pole loading, not as much. If you're looking at full classification because you only want to do change detection on DEM across different things, not much. But if you want to go in and classify to 18 feature codes, then usually you're going to need manual editing on that part. So.
All right, Randy, thank you very much.
All right.
Appreciate your presentation. Appreciate your support.
Thank you, Mark. Appreciate it. Thank you so much.